So in section 4 of chapter 8, we turned our attention to rational functions. And the first function that we looked at was 1 over x. It turns out this is a parent function for a host of a bunch of similar functions. I can add a value k to this function or subtract a value k from it. And whenever I do that, if I add a value k to it or subtract k from it, it just has the effect of taking the entire curve and moving it, either up or down. So it kind of seems like it's changing its shape, but it's not. It's just moving exactly up and moving exactly down. The other thing that I can do is in the denominator of the 1 over x, where the x is at, I can subtract an h value. Now, if I subtract an h, it moves to the left. So this is a little tricky, and we've been down this road before, but this is 1 over x minus negative 2. So you can see when I'm subtracting h, when h is negative, it moves this function over to the left. And if h is, let me grab this slider that I'm using over here. So this is the slider that I'm using for h. And you can see right now my current value of h is negative 2, and it had the effect of moving this function to the left. If I bring back h over to 0, right there where I started, and as h gets positive, of course, it's moving it to the right, and I'll go all the way to positive 3. But notice that what this function looks like, it's 1 over x minus 3, right? Because it's minus the value of h. Not true for k, right? With k, let me grab that slider and bring it over. Oops. Here's k. If k is positive, it's pushing it up. If k is negative, it's pushing it down. So I've asked the parent function to stay that's the dotted line, right? So basically all I'm doing here is I'm manipulating this function by moving it up or down. The other thing that they had in the textbook was they had a value of a up here in the numerator. Right now a is 1, but I want you to look at what happens as a becomes positive. And if a is in this region right here between 0 and 1, see, it gets closer and closer. Now, as soon as a becomes 0, this function flatlines, and it's just the line. It's just the line y equals 2. And then if I flip it, it becomes negative. It goes off the other direction here, right? So this value of a is just handling compression and stretching of the function. Okay, so that's a look at the first rational function that we looked at in section 8. Again, the general form was 1 over, it was a over x minus h plus k. One of the things that they talked about, and we should make sure we address here, is that this function does have, let me set this back at 1. This function does have an asymptote. In fact, whoops, I want that to be, and I want this to go back to 0 also. Whoops. Yeah. There is an asymptote here at the line y equals 0, or the x-axis. And if I add or subtract to it, that moves that. This is a horizontal asymptote. It'll move it up or down. And then also there's a vertical asymptote that's affected by the value of h, right? So if I move it this way or this way, you can see that vertical asymptote it's right there at the value that h is, right? So if h is 1, there's a vertical asymptote that's just right up and down here. Take a look again at, our textbook talks about what an asymptote is, and it kind of gives you a discussion about that. You probably should review what that means to have an asymptote of a function and think about that. All right, we're done here.